Hey and welcome everyone. Today on Skylines Summer Sessions, myself and Richard are joined by Pete Gallagher, who lives in England, and Pete is an Azure MVP. A very warm welcome, Pete. Great to have you on today's show.
Thanks for having me.
Yeah, no worries, no problem. Today you're going to be talking to us a little bit about IoT along with Azure. So to kick things off, Pete, tell us a bit about yourself and what you do day to day.
Hi, so as eloquently put, I'm Pete Gallagher. I'm a freelance software developer and an Azure MVP. Relatively new one, 2021, but yeah, since October last year. So I don't think I've been in the program as long as Greg's been in it. But no, it's good. So I basically swap my time for money, but mostly in the IoT space. But I'm happy to do anything from websites all the way through to embedded programming. Pretty much anything anybody will pay me to do. Maybe not dance in the rain. Well, depends on the hourly rate, I suppose.
Sounds fun. So what got you started with IoT? Like all these other cool development stuff. Why IoT?
Well, it's mega cool, obviously. But I've been doing IoT since before there was really an IoT term, way back in sort of the late 90s. I worked for a company called Thomas Automatics, and we made change machines and kiosks and cash handling stuff. And one of the first projects that I got involved with, I took over from another programmer when I joined, which was a Royal Mail stamp vending machine. And we'd built a modem into it, and you could dial into the stamp vending machine and get all of the stock levels and error codes and the whole history of how the machine was being used. And that was sort of one of the first things that I got involved with straight from university as my first job. So I was kind of hooked. I always knew I wanted to do embedded software because I did electronics and electrical engineering at college and university. So that was my background, but I knew that I liked the programming side sort of more really than electronic and electrical theory. So getting a job that combined both of those was great, and that was IoT from the get-go really.
Cool. So Pete, you're an Azure MVP. In fact, we're all Azure MVPs. I've got a developer background, as do you. So tell me, what's out there for IoT developers? What kind of things can people do and play with?
Yeah, I mean, as you say, I'm an Azure MVP, so I lean heavily towards that stack. But I've had exposure to the Amazon AWS IoT stack as well, and it's good. And obviously, if you like things like Alexa, then it's good for that. But I find the Azure one's far more built out for devices and security. And the good thing is that the learning material, the docs and things that Microsoft have produced are awesome to get you going. And to couple with that, they've got some online simulators available, so you don't even need the hardware to get started, which takes one of the big barriers away from people because there's just so much hardware out there. It's just very difficult to try and find a place to start. And obviously there's a cost involved with that, and if you get your decisions wrong, then there's more cost involved in fixing the bad choices. So yeah, their whole IoT platform, which I'm guessing I'll show in a little bit, is fantastic and dead easy to get started with.
Nice.
Cool. So you've just mentioned about showing us. Why don't you go ahead and show us some of this cool stuff?
Yeah, let's do it. Hold on. I will start with where I said. So this here is a Raspberry Pi simulator. Now, assuming that you can see that, then this is, I mean, obviously a Raspberry Pi is a great place to start for any IoT project. I mean, it was designed there by Eben Upton and his team to be able to remove that barrier of hardware and software to be able to give you a platform to develop on. But having said that, you've still got to go and buy one. And if you've not got any kit whatsoever, you're going to need a power supply and an SD card and a keyboard and a mouse and a monitor. And then you're going to have to get Raspbian installed, and then whatever stack you want to use installed on there as well. And that's just way more steps than a lot of people want to go through. They just want to see, I want to play with the Azure IoT stuff, but I really don't want to have to bother doing all of that. It's just going to take me too long. So that's why they've created this in particular. This simulator is fantastic. This is all in Node here on the right-hand side. So you can see there's not much to it. There's a connection string there on the top right, and then there's some code that lives on the right hand side. For zoom in a little bit, might make it a bit easier. And you can go ahead and edit this code if you like, but you don't really need to for just getting started. All you need to do is paste in your connection string, and you're off and running. So obviously, there's no good just running this because you won't have the necessary IoT bits. But there's a help section here, and this guides you through everything you need to be able to do to be able to get an IoT hub in this case, which is like a switchboard, if you think of it, for devices that lives at the edge of Azure. So it ingresses all of your messages and contains a registry of all your devices, and you can set up things like device twins in there. And you find that over here. So this is an IoT hub that I created earlier in Blue Peter fashion. And you come in here, and it doesn't tell you a great deal here, but you can set up access policies for devices to be able to connect in, to be able to manage devices. And then over here, you have your list of IoT devices, and I've already created a couple in here. So there's a Raspberry Pi sitting in the devices, and at that point, you get access to the connection strings and primary keys. And these are used for the authentication, the attestation for the device to be able to connect into the IoT hub. But you don't need to take too much of that in when you're getting started. You can just go and follow the steps, create an IoT hub, create a device like this, and then copy that connection string. And you paste that connection string in here where it tells you to paste it. I've already got one pasted in here. And then you hit run, and it starts sending messages up to IoT hub, which is okay. But that doesn't actually tell you very much unless you can see what those messages are actually arriving. So if I switch my sharing there to, hold on a minute, share my screen. Actually, I'll just share this. So this is an IoT Explorer, and do tell me if that's too small. But there's a different connection string here. This is an IoT Hub level connection string that allows this application to be able to gain access to that top level IoT Hub. And you can see here's my devices. You didn't see this device before because that's an edge device. But you can see we've got, but I can go into my Raspberry Pi and I can get those same bits of connection details out from here, but I can also go to telemetry on the left, and I can start monitoring the IoT Hub level for that device. And that's going to sit and wait for messages to start appearing. Now, you won't see this because I'm not sharing this part of the screen, but I've just flicked back to the simulator and told it to run. And now it's sending messages up to the IoT Hub, and there, if you can see underneath receiving events, they're the messages that are coming from that simulator. So that's come from the web simulator and gone up to IoT Hub. And then I've got an application running on my computer that's monitoring those messages on the IoT Hub and then just squirting them out in the console there. And obviously, I've not shown you how to create an IoT Hub, but there's not many steps to get between those two. So it really does give you a good place to start if you just wanted to sort of prove that you can, see how that all works. And obviously, it's open source. All of this is open source, including this Iot Explorer. You can just go ahead and go onto GitHub and download the source for all of this and then get going. And this is just a WPF app. So that's dead easy. If I switch to sharing my browser again, there's another device called an MXChip that Microsoft have partnered with a company to make, and that's based on an Arduino. So the difference between these two things is, of course, a Raspberry Pi is a full computer, and an Arduino is a microcontroller, so it doesn't have an operating system as such. That just runs code, a microcontroller, so it's far more lightweight. And so if I switch to the DevKit simulator, zoom back out again, then on the right-hand side, this is a mock-up of an MXChip device. So it's got an Arduino compatible processor on there, but it's also got a temperature sensor and a humidity sensor and a gyroscope and a magnetometer and stuff like that. So if you've ever seen a microbit, then it's a very similar form factor to that. But this is kind of like an ESP32. I think it might have an ESP8266 or a variant of that sitting. This is the processor part here with the Wi-Fi module built into it. But there's a bunch of, if I go here, Then if you're used to Arduino programming, then you get a .ino file, and that's where the majority of the code is. And I've not had to write this. This is all just predefined. The only thing you need to do is down here is stick in that same connection string that we had from earlier. And then you just hit the run button at the top. So if I stop that and then run it again, and just give it a sec, and it powers up. I might need to refresh the page because I've left it going too long. Let's refresh that. Press run. So it says it's connecting to the IoT Hub. It should do that. And now it wants me to press this little A button. So this thing's got a couple of buttons and a little OLED on it as well, which is dead good. In fact, somebody rickrolled that same OLED I saw. That was quite a cool little demo of a GIF on there. So I can actually shake it and it recognizes that, which is cool. And again, you can modify this code, but it's all in C, this is. If you know anything about Arduino, then you'll know that. So if I switch my screen share, I probably should have shared the whole screen, but you won't notice this, but I've got a 49-inch monitor here, and you have to share a portion of it, and it's just a bit messy, and I didn't see that as necessary. If I switch back to my IoT Explorer, and I think, is it appearing at the bottom or the top? If I clear the events and press start, I probably should have done that before. Let me get my browser back up again and just run that again. One tick. Switch back. And there. So that's the MXChip device sending a message. So it's very similar, but it does give you two different angles. So if you're interested in the Raspberry Pi flavor, then you've got some code for that and an online simulator. And if you're interested more in the lower level Arduino stuff, maybe for real-time processing and stuff, then you've got a simulator for that as well, which is fantastic. Obviously, this gives you access directly into the IoT Hub. Once you've got that, then you've got access through Event Hub or Service Bus or Event Grid or onwards to whatever parts of Azure you like. Logic Apps tends to be a good one. I built a little demo where it sends a tweet if the temperature's too high, and I had a little temperature sensor connected to the Raspberry Pi. And so, you know, if your house is burning down, at least if you're out, you know it's going to happen. If I stop that from, yeah, what am I sharing at the moment? My browser or not? No.
I've got Azure IoT Explorer.
Yeah, good. I'll switch back to the browser. So that's great if you're sort of quite competent with Azure, but if you're not, they've got a platform called IoT Central, which is fantastic. And I've got a little demo app set up here. I've got an ESP32 in the other corner of my room over there. I've not got one to hand. That's all my little demo ones on the other side of the room. But that's like an ESP8266, which is a microcontroller with Wi-Fi on board. And an ESP32 bundles that and a bit more RAM and Bluetooth. And I've got some Bluetooth sensors that squirt out this temperature, humidity, and light level. And I'm reading that with an ESP32. It's a little bit of a pain because you can't do Bluetooth and Wi-Fi at the same time. So you have to do a whole reset routine to be able to flick between them. But that aside, there's some demo code out there that lets you connect up to IoT Central. And I basically took that, and it didn't take me all that long to take this code that grabbed the Bluetooth data and then couple it up to the stuff that goes to IoT Central. So this is a whole platform that they've built here that gives you access to nice, pretty graphs like this and device management. If I go to the devices here, then I've got 3 devices sitting there, and you can set them up with templates, if you will, so that it knows what data is going to get posted into what area and what capabilities they've got. And when you've got data coming in, you've got access to time series insights. So here, if I select my devices and then select which items I want to put in there, I've had this running for quite a few weeks, although it did crash and I lost some data. I'm just telling it I want humidity, light level, and temperature, and I'm just going to split this by the device ID. I've only got 3 devices. So you can drag this across and you can get some more data. So this is, I don't know, the last 30 days or something, is it? 2 weeks worth of data. So you can see the light level peaking while I'm up in the day and in the office, and then you've got the temperature going up and down during that period. And man, 31.3 degrees it was on the 12th, and it was hot that day. But this is the sort of stuff that you can do with this, and obviously once you've got that, you can actually grab it and do other things like export it as a CSV or view it as a table, so you can view the actual results. That's going to be slow, but yeah, that's all of the data across their individual packets that are sent. But you're not stuck in IoT Central, and I've made applications for clients where you can export that data out to other services, like Service Bus or Event Grid or straight to blob storage. And once you've done that, then you can write, say, an Azure function and store it all in a SQL database if you don't like it stored in there, or export it out to a web app, or then anything. The world's your oyster at that point. So yeah, they're cool. But the one last thing I wanted to show that's Microsofty is something called Make Code for the microbit. And if you've not heard of microbit, it's a tiny little sort of credit card size microcontroller system, really aimed at children, but it's pretty powerful actually. And Microsoft have made a Scratch-based program for it. So let's just call it Hello, because I'm inventive with my names today. So if you've used Scratch, then you'll recognize this. So it's a block-based programming paradigm, and it's often scoffed at, block-based programming paradigms, but it's becoming more and more popular. And in fact, if you've used Logic apps or Power Apps, then you've used a block-based drag and drop programming paradigm already. And if you've used both of those, you know how powerful they can be. But this again is a simulator, and what's good is that you can switch to Python if you like, and you can write all of this like in Python, or you can actually write it in JavaScript if you wanted to as well. So you've got some options if you wanted to sort of, you weren't an expert programmer, you wanted to play with some IoT stuff, you can start with blocks, but then you can switch to JavaScript and see what the code actually looks like. Stay in JavaScript all the time. But if I grab, say, let's put that on start back because that's disappeared. This just allows you to drag in bits like when it starts, I can tell it to show an icon, and there we are. So that's that same icon, or I can show a different icon. I'm not going to labour this too much. It's pretty cool, but I tend to show demos where down here in pins, you can drag a virtual servo on there, and when you do that, on the left-hand side, a real servo appears on the left-hand side. Well, a real simulated servo, and that allows you to be able to move that servo around. So I can go to input here and drag a button on, and then go back to pins. In fact, let's move that to there, and then do another input for the B button. There's two buttons, A and B, and they actually work. Go back to pins, drag another servo on there, and tell that to go to 0. And now when I press these buttons, when it's finished reloading, press A, press B, and what you've got there is the basis of a robot arm. So if you imagine that servo is connected to a robot arm that's doing that, then you've made simulated hardware there just by dragging 2 blocks onto the screen. It's pretty powerful. I like that. And obviously you can do more complicated things with these things. I made a faux Enigma machine with one. Now obviously you can see there's a few inputs and outputs on here, but not very many. But it's actually got SPI and I2C serial interfaces on here, which means that you can add things like IO expanders to that. And I made an IO expansion library with this. You can make your own libraries to be able to control an IO expander chip. And I had 3 IO expanders and a shed load of buttons, one for each letter of the alphabet. And I wired them all up to these IO. It took ages. It was actually a project for Coventry Transport Museum. I have a friend who works down there, and they were doing a World War II day, and they wanted something for that. But what it allowed you to do was, once you got it working and showing the letters on the screen when you press the buttons, you could pick a wire up and swap it with another wire, and then effectively what you've done is made a really basic letter substitution encryption machine, not too dissimilar to the Enigma machine. I didn't take it much further than that. It was proof of concept, but that's a reasonably powerful thing to do with this little device. And all you need to do is download the code and copy it onto your microbit, and off you go. It's quite powerful.
That does look
Yeah,
cool.
that's the sort of a very, very quick tour of the Microsofty bits. There's other things you might see on the tabs there, but I don't want to sit here forever demoing. But yeah, one called Tinkercad, and that's amazingly powerful. This allows you to. It's got a circuit playground in it. It's also got a CAD program, but there's one for circuits, and you can drag an Arduino onto that and write your code for the Arduino and hook up LEDs and resistors and buttons and servos to that, and run that code in there virtually without having to go and buy all of the kit. That's pretty powerful, that is. And then there's this Sense Hat emulator for the Raspberry Pi. There's 2 Raspberry Pis on the space station, which is dead cool, and they're running experiments like this, pretty much like this. So Tim Peake, when he went up there, took 2 of these up there, and every year they have a competition, an AstroPi competition, where kids at schools can write experiments, and the best experiments get sent to the space station and run, and they get the results back. And this simulator allows you to be able to write those experiments. Dead cool.
That is
This is stuff I like doing.
I can see why.
Yeah, definitely looks fun. That's cool. That's really cool. Yeah, I'm impressed.
See, I've heard about Azure IoT Hub device twins. What is that, and what are they?
So yeah, the IoT Hub. If I go back to this and go to devices here, so it's I kind of touched on it earlier. If you imagine that you've got I always extrapolate it this way. If you've got a bunch of houses with telephones in there, they need to connect to like a BT exchange, and then that needs to get routed around. This IoT Hub is essentially that exchange system where you've got all of your devices and they're able to connect up to the IoT Hub, and you can manage devices, individual authentication on that level, and you can send commands down to the devices. But the messages that come up, you can then route out, so you can apply properties to them. And then you can filter those properties and apply routes to them to be able to send them certain ways. So one of them would be to send it like to a service bus, for instance, if, say, one of the properties is that the temperature is critical, which was my example of the Logic app that tweeted out. So stuff that goes onto that service bus, then you can then hook in something like a Logic app that monitors the service bus, grabs that message, and then does something with it. Or maybe you just want to send it out to cold storage and keep it forever, or maybe you want to send it to streaming analytics or time series insights or one of those other services. So it kind of sits right at the edge of the cloud. And it performs like a gateway functionality for your devices. So that's an IoT Hub, but within that you have a device, and then you have, for each device, you get, if you've got more than the basic level of IoT Hub, there's tiers, as with anything in Azure. You'll get something called a device twin baked into it. And what that allows you to do is, say you've got like a Raspberry Pi that's controlling a fan, and you want to be able to set the speed of that fan. You can do that with a device twin. Now, with any IoT device, what can happen is it can go offline. The internet goes dead at the location where the device is. But you still need to be able to, say you've got maybe air conditioning for a block of flats, and you want to set the threshold for that to be a particular level, but you don't want to have to keep trying to send it until it tells you that it's online. With a device twin, you can set it once, and when the IoT device connects up, one of the first things it will do is synchronize that the state of that device twin, and you have desired properties and then reported properties within that. So the desired properties are what you'd set on the hub, and that gets read then by the IoT device, and once it's done it, it'll set it in its reported properties to say that's happened. And you can do way more than that. You can do jobs in there as well, so that you can apply tags to, say you only wanted to do that on the 13th floor of your block of flats, then you could tag all of your devices with a floor number, and you could set a job up that just went out and set all of the properties on those desired, on those device twins to be desired for that particular level for those particular sets of devices, and it will just go off and run that job for you. So it's pretty powerful. However, there is something called an Azure device twin platform. And there's actually 2 of them, and one of them has been deprecated, I think, as far as I can work out, and one of them is being used as like a super private preview for some bigger companies. But that's a whole system to be able to map the location of devices. So if you imagine you've got, I don't know, like a campus of devices out there, you can map where they are in a schema. and what you want them to do and what they can do. But it's sort of a way of designing the topology of an IoT system rather than it sort of just being left to your own devices. It's pretty powerful. I've played with it. It does work quite well. But I think there's going to be a big step between what they've got now and what's in private preview. So I've not taken it too far because it's kind of, I don't know, like as soon as you get an inkling that something's going away and you can't play with the latest one, it's like, I'm not going to do anything with that for now because it just seems like it might be a waste of time. But there's some big companies using the device twins out there already. So it's this industry 4.0 business where you can do predictive maintenance and analytics and stuff like that. That's sort of where it's heading with that. It's pretty cool.
Cool. Sounds good. So earlier you mentioned about Microsoft Learn is a good place to learn about IoT. Is there like anywhere else, or is there some exams our listeners, viewers can do with IoT and Azure?
Yep, absolutely. It's quite a new exam. It's AZ220. It's the IoT Expert Exam. You only need to take one exam and then do a little bit of learning material, and then you get the AZ220. I'm listening to the Americans too much, I think. But I was actually involved in creating that exam as well. So that was quite interesting that was the first exam that I was involved in creating, and it was really interesting to be on that side of things. And I learned a heap, actually, because, of course, you've got this thing called an objective domain document. And if you're ever going to do an exam, and this would be one of them. And in fact, am I still sharing my screen? I think I am, aren't I?
Yep.
So I can just go to the IoT exam over here. Here we are. So obviously, you've got all the information about it here, but it's a really good way of gauging where you are in this whole path. But scrolling down here, you've actually got a learning path. So this is relatively new content here as well. So you see, I've not gone through a massive amount of it, but this is curated learning material directly from Microsoft, tailored towards the exam. So if you go through all of that, then you'll pretty much be able to pass it. I mean, obviously, doing the hands-on practical stuff that an instructor would give you will be more targeted, and you'll get better experience out of that probably. But these learning paths here are fantastic for exactly that. So yeah, this is an Azure IoT Developer Speciality, as it's called. And yeah, it's well worth doing, or at least well worth studying for, if nothing else. And yeah, it just gives you a little bit of an edge if you've got that exam, I'd say.
That might be next on my list.
Yeah, it's fun. Obviously, let me know if you need a hand, but I'm not going to give you the answers.
So, Pete, .NET Core 3 is cross-platform now. What can you run that on?
Yeah, that's awesome. So yeah, you can run that thing on obviously Windows devices, but also Mac and Linux. And we were talking about the Raspberry Pi earlier, and that is a Linux-based device, Debian, in fact. So that will happily run .NET Core 3. So console apps, it won't run WPF or WinForms because, you know, the W in both of those is Windows. So good luck with that. Although they are walking down a path slowly to be able to give us that functionality, I think. There's bits and bobs happening. I mean, obviously we can't do much about the Windows element in there, but there's things like GTK that I think perhaps we can leverage to be able to, you know, a bit like Xamarin does, to be able to leverage the native controls on devices. I think we'll be able to do something with that, or at least that's what I'm hoping, because just writing C and GTK is terrible. Sorry if you like that, but you know, it's WPF's my bag if I'm going to do anything like that. So yeah, actually getting it installed is quite arduous, and there's not that much data out there for it, but I went through the pain of doing it, and I've created a single line installer. So it's just a bash script that I've got sitting in my Azure, my repo, my .NET Core on the Pi repo, and you can just hit that, just download that script and run it, and it'll just install all of the prerequisites to get .NET Core 3 3.1.313 or whatever the latest one is installed on there, just in one go. It doesn't take very long. Certainly if you've got a Raspberry Pi 4, then you're talking a minute or so and it's installed. And then you can do, obviously, create console apps, but you can also make Blazor apps and serve them from your Pi, and it works really well, certainly on a Pi 4. And I've got plenty of demos for those, but it's a little bit out of scope, I'd say, for what we want to do. But yeah, it works really well. And then you can take your C# coding skills down onto a Pi. Make dashboards sitting in there if you like, or there's a whole library of third-party software in there to control chips like IO expanders and temperature and humidity controllers and motor drivers and even the Pi hat. So in that Tinkercad program I showed you, it had little matrix of in fact, just flip back and, oh no, not Tinkercad, the Sense Hat emulator rather. This has got a hat underneath there, hardware attached on top, and it's got buttons and a little joystick and a magnetometer and some LEDs and stuff, and you can control that with your C# code on a Raspberry Pi, rather than perhaps you don't like writing in Python or you've got no experience. So these are good things because it gives you a starting point. Somebody's already made some hardware there for you to be able to interface to and get working, and you know that hardware is going to work. So yeah, that's pretty powerful stuff to be able to run .NET Core. So if you're in the Microsoft space and you want to transfer your skills to embedded and IoT, then you can do that now. It's pretty cool. A little bit of a stretch, not really .NET Core, but you can run .NET on an Arduino as well. I can't remember what it's called now, but it's a little tiny device. It'll come to me immediately when I finish that, but it runs a .NET stack on it. So if you don't want to have to write C for Arduino, and let's face it, who wants to write C? It's hard. Then you can run that directly on this device. Oh, geez, I'm gonna have to look it up. No, it's not going to give it me straight away. I think it begins with a W. There you go. I'm getting old. My memory is not as good as it used to be.
If we remember it, if you find it
Wilderness Labs. That's what it's called.
Oh, yeah.
Yeah, geez. I told you it began with a W. Yeah, the meadow. There it is. So, yeah, this thing will run .NET in there. So, .NET, full .NET standard applications. And again, obviously, don't expect to get any display stuff out of it. It's not going to give you that. But these things are relatively cheap too. So, yeah, pretty cool.
Cool. So I'm guessing you've learned a lot about different IoT projects other people are doing in that. What's the best one that you're aware of? What gets you excited?
Well, I mean, I'm doing one for a client at the moment that's using those sensors. I can't tell you a great deal about it, but they're looking at how buildings warm up and cool down. And that was dead cool because I got to use all of the bits of Azure that I'd sort of spent a long time looking at, but not having a massive amount of application for it. So this was the first company I got involved with a few years back now that needed all of that stuff. And I went and sat down with them and they gave me the brief of what they wanted to do. And I just, yeah, I could do that, I could do that, I could do that. All of these bits all just to fall into place. And they're doing it with IoT Central, as it happens. We could have done it all bespoke, but it just gives you so much to do in there. But I mean, I like playing with, I like the fun stuff just as much as the client-led stuff, actually. I mean, that's a good example of the client-led stuff where you've got IoT Central and Azure Functions and SQL database storage and a Blazor web app, and we hook it up to time series insights and we can get stuff out of that, and we can send messages forwards and backwards. And yeah, it sort of demonstrates the industry level stuff. But I like playing with little devices and just, even just that little temperature sensor with a Raspberry Pi sending tweets out. That's just fun. Mm-hmm. And it's a great way to learn, actually. And just going and grabbing a project like that and doing something with it. Obviously, I mean, John Skeet's a good example of hacking an IoT project. He hacked a MIDI drum kit and he hooked that up then to a WPF app on his machine, and he was able to download drum kit sounds into it and fiddle with that and taught himself to play the drums on it. And that was just a spare time project for him, but actually taught himself quite a lot of WPF doing it more than anything. And obviously the MIDI standards and MIDI over USB and stuff like that. But yeah, I think you could learn, so long as you kind of focus and don't give up when it gets hard. You could learn a heck of a lot just by playing with the kit. And I mean, I made a tiny little, and again, I probably should have brought all these little bits over there, but I had a Raspberry Pi Zero with a camera in it, and it took a photo of you and it sent it up to Azure Cognitive Services, and then analysed what emotion you had, and it sent it back down, and I had a little display on there, and it put a smiley face if you were happy or a sad face if you were sad, and then it would take that result and tweet that out with a picture of the image, and it would stick on emojis onto that depending on which one you had. But I mean, that taught me loads. I mean, I did all that in Python because I wanted to teach myself some Python. But just doing the Azure Cog Services stuff was really interesting with that. And I took that knowledge I learned and went out to Lincoln Hack, for instance, and I won Lincoln Hack the first time I went there, like a few years back, making a camera that would obscure people's faces for kids at schools. And that was dead fun. And we made a zombie detecting machine there last year, where it would analyze video. This was all offline. I used TensorFlow actually on the Pi, and it would analyze video, and it would detect the difference between somebody who was a zombie and somebody who was okay. So if zombie Bill Gates turned up at your door, then it would lock it and you wouldn't be allowed in. It was good.
Nice. Cool. Okay, so we've got a couple of fun questions for you just before we finish up, Peter. So you run a lot of meetups. Tell us about them if you can. I'd love to know a little bit more about what the kind of things you do.
Yeah, I mean, I must just have too much time on my hands. Having kids in a job isn't enough, obviously. But yeah, I run Knots IoT, so obviously you're well aware at this point that that IoT is my bag. So a good while ago, when I first started speaking at events, I did an IoT demo, and then I thought, well, I'm going to try and tap this around, see if I could give it anywhere else. And I found a dormant IoT meetup in Nottingham. Got to to concentrate on some other things for a while, so I ended up running that for a little bit, and then pandemics happened, and in-person stuff doesn't happen, and online workshops are just difficult to curate. It's just a difficult thing to do. Ask NDC how hard that is. But a couple of years back now as well, I've been going to our .NET meetup, .NET Knots for years. That's the first meetup I ever went to. Yeah, I don't know, probably 10, 11 years ago. It's been running for a long time. But the two organisers of that, Marvin and Weir, and Marvin, he runs his own company and he just didn't have the time. And Weir, he's been doing mostly Amazon Stack stuff, and he's just not been involved in the .NET stuff. So he approached me and wondered if I could help. He knew that I'd had experience running meetups now, and wondered if I could take over .NET Knots. So I've been running that now for the last 18 months maybe, and I realised that it's just a difficult thing to run on your own. So I invited Jess White, who's another Microsoft MVP. She's fantastic, to help out. And in fact, as soon as she said yes, I was over the moon with that anyway. But she then started doing all of this stuff that I'd wanted to be able to do, but not had time to do, updating the website and making a code of conduct and stuff like the really important stuff that I'd sort of been putting off, that Jess has jumped on. She's, I call her Scrappy Doo because she seems to have an endless supply of energy. She's just awesome. So it's good to work with her to do that as well. I'm also a board member of a group called LATI. It's a Loughborough-based high-tech science meetup, where we tend to do a lot of things like company visits, where you go around cool tech companies or cool science companies and have a look what they do, and they give a talk. We had a latte bar that we met in a pub, and you come along and have a couple of pints and there'd be a speaker. But of course, both of those two things have been off the menu since COVID as well. So we've not been doing a great deal with that, but that's a really fun sort of different idea, more sort of a networking event than it is a meetup, but it's pretty cool.
Cool. So apart from IoT, family, all these meetups, what do you do? Anything else in any spare time? What do you do to relax?
Oh, to relax? What you mean, other than Star Trek? Well, I find what I do relaxing. Certainly, assuming it's working, that is. I love to learn stuff, which is why I like building all of these stupid little toys, robot arms, and stuff like that. Just because I'm learning something. But I also speak, used to be around the country, still is around the country, but it's virtually now. So I quite like doing that because I tend to focus on sort of lower level, so 200 level to 300 level talks rather than the in-depth stuff. And they're fantastic. But I like sort of the getting started level more fun stuff, the stuff you can have a little bit of a laugh with, and it's not too serious. And I like that sort of stuff. So I write quite a lot of getting started IoT talks, and a lot of the stuff that I demo today, that's included in one of my main getting started with IoT with nothing but your laptop talks. And that one goes down really well. I'm writing one at the minute about the history of IoT. Only I think I've gone a little bit off topic because this history of IoT is turning out to be going a little bit back in time to like the mid 1800s. So, but what I've done to make it a little bit more fun is I've got a bunch of science experiments that demonstrate some of the tech that happened during that time, and I've never seen it a talk done that way before. So I'm really looking forward to seeing how that goes down. But I've got a bunch of stuff that you can't see because you've got bit here. Mainly because my office is upside down with all of the stuff that I've got behind me, but there's quite a few little experiments sitting just behind me to my right where I've made some stuff. And I don't want to give away too much because that's going to be at TechFest a week on Thursday, but it's 8 a.m. So, you know, if you like your sleep, then it's probably not the best time. But you can turn it on while you're in bed, I'm sure. But go check that out on Meetup and see. I've never given it, so I'm pretty sure that everything will go wrong. But there's not actually very much in the way of code demos in an IoT talk, which is interesting.
Cool. So, Pete, many thanks for taking time out today to spend talking with myself and Richard.
Anytime.
We've learned a lot about IoT and Azure.
Definitely.
Yeah, we're going to go off and have a play around with it and experiment. I think it's the right word, not play around, experiment.
Definitely, experimenting. It's awesome.
I'm also going to go and have a wee look at the exam as well. So thanks for taking your time out and appreciate that. Thank you.
Anytime. Yeah, thanks for having me.
Thank you.